So, hi guys, this is Miss Arneson. I'm going to talk to you about something called the system. It's like the matrix in my mind because I'm a nerd. And so I think of the system being this thing that's all around. And it kind of is, it just depends on what you're studying. So, we're going to talk about the system thermodynamically speaking. Thermodynamics is one of those big science disciplines that covers basically all other sciences. Like, for example, the first law of thermodynamics, you guys already know, is that matter and energy can't be created or destroyed except by the Big Bang. All of that energy has been like recycled and reused and turned into matter, turned into energy over time. So that's the first law of thermodynamics, and that basically applies to like all sciences. So this is a thermodynamic concept, the system, and let's talk a little bit about what it means. Okay, in regular life, you have undoubtedly heard the word system, the solar system, a sprinkler system, digestive system, the nervous systems. These are actually some pictures of from some operating systems. So there's like Windows and Apple, Android. And then if you know what this one is, then you are a true nerd. Um, if you have one of these, then you are in the nerdiest percentile of people that exist. I do not have one of these, but I do know what it is. So that's where it puts me on the spectrum. So this is the Linux operating system, and that is for like true super nerds. And really, when we use system in these terms, we are using the word just like it would be used in science. When we're talking about the digestive system, we're referring to certain parts of the body. When we're talking about a sprinkler system, we're referring to all of these pipes and hoses and sprinkler heads that are in our sprinkler system. And so we're using the word like it would be used in science, but it's kind of hard to think like, okay, well, what do my guts, my guts over here and the planets have to do with each other? Like, that doesn't make sense. And so really a system is a way to define something that you're studying. In science, a lot of times we use something called a model. A model is a representation of something that's a lot more complicated, but we've kind of broken it down to its most basic components. And when you're looking at a system, there are three basic components that make it up. You should definitely write these down because this is going to be something we refer to in the rest of your science classes, even next year. So a system, the definition of that, and this isn't a very it doesn't sound very sophisticated, but it's a really good definition to describe what a system is. Are you ready? It is the thing you are studying. Okay, that's what a system is. So if you're studying I don't know, one type of bird, then that's your system. If you're studying a pond, that's your system. If you're studying how long it takes your cheese to mold, that's your system. So it's just whatever you are studying. I study a lot of times my face is a system because I use like different kinds of face creams and makeups and stuff. And so that would technically be a system if I was coming at it from a scientific approach, which I do because I'm a scientist. Okay, the boundary and the surroundings, actually those words, you're probably familiar with those as well. And so they kind of have easy definitions. The boundary is the edge of the system. I would write that down. So the edges of the system would be considered the boundaries of that system. And then of course, everything that's not the system, so everything that's around it, would be called the surroundings. So you should write that down too. So everything that's around the system, outside of the boundary, would be the surroundings. So that's pretty simple. And I like that because a lot of times in science, something is hard. And when it breaks down so simple, I love it. There's three types of systems that we define in science. And one of them is called the isolated system. All the systems are going to be defined by whether or not they let matter and energy cross the boundary. So an isolated system, isolated is all alone, like Miss Arneson in the COVID. Okay, I'm all alone. Okay, isolated here means that the exchange of energy and matter cannot happen across the boundary. Can't get matter across it, can't get energy across it. So you can't get energy in or out, you can't get matter in or out. And so the isolated system is completely separated from the surroundings. The closest thing we have come up with is basically like a thermos. You know how a thermos is supposed to trap like the heat or the cold inside of your drink? That's as close as we can come, but you can still get energy in and out of those. It's just really slow. So we just slow down the rate of the energy moving. So we don't really have in science an observed isolated system yet. We don't have one that we've ever seen. A closed system, and this is super annoying because it's called closed, but it actually doesn't mean that. It means that only energy can get in and out of it. So matter can't get in or out, but energy can. And then an open system can let both matter and energy in and out. So I really like this model, and if you want to copy down this in your notes as well, that'll be helpful to you in your future classes for science as well. Okay, so I like to do some identification of systems. I chose Chadwick Boseman because he recently passed away, and a lot of people were surprised. We didn't even know that he had cancer. And so if we were his doctor, like his oncologist, then he would have been our system. So the boundaries would be like his skin, the surroundings would be everything else like in his house, the food that he's eating, and then he would put it inside of his system. So we have to look at this and see, like, are energy and matter moving into and out of Chadwick Boseman? Yes, they would have been. So his doctor would have probably been concerned about what he was eating and giving him chemotherapy. There might have been even some surgeries. Does energy come in or out of Chadwick Boseman? Yeah, so if you shook his hand when he was alive, if you had been lucky enough to meet him, then you would have noticed like his hand is warm because he's giving off thermal energy. So Chadwick Boseman or any person or any living thing would be considered an open system because matter and energy both can go in and out of them. So here's one that's a little trickier in my opinion. It's the cell phone. This is some kind of Samsung expensive phone. I don't even know. I buy the cheap ones. So if we were looking at the system, what is the thing we are studying? Well, we'd be studying the cell phone. What would the boundary be? The edges of the cell phone, so the outside of it. And then the surroundings, of course, is everything around it. Now, what type of system is this? Is it isolated, closed, or open? We can get rid of isolated because those just don't really exist in nature, like in where we observed. And so we would only have to choose between open and closed. So is matter getting in and out of this, or is only energy getting in and out of this? I would say only energy. Like you plug it in, but energy goes into your phone and then it stores that energy in the battery, and then the energy comes out as like light and sound from your phone. So I would call this definitely an closed system. Okay, here's one more. Here's that great picture that you guys, I'm sure, recall its name, Earthrise. If we're looking at the Earth and we're considering it a system, I think you could argue that it's closed or open depending on what you're studying. So if you were studying like global warming, then I would call it closed because all of the things that are happening with global warming have to do with energy coming into the Earth, but not being able to leave because of things that we have done on this planet to make like pollution and stuff that insulates the Earth from that heat energy being able to leave. But if we were talking about the Earth in terms of how water got on the Earth in the early solar system, we would have to call it an open system because the way that we think that we got water covering the surface of our planet, because it used to be so hot, water wouldn't have stayed on the surface. It would have evaporated out into space. But we think that the way it got back on is that like asteroids that had a lot of water, comets that have a lot of water would crash into the Earth, and that water melted and stayed on our planet. So in that case, you'd have matter and energy coming into the system. So I think you can argue sometimes that something is open or closed. It just depends on what about that system that you're studying. Well, I hope you all have a good day. I'm trying to find out how to close my button. I can't see it. I can't see the button. Hold on, let me close X. Okay, there we go, I think. No. No! Where is it?
Are you still recording?
Yes.
Okay.
Look,
Okay.
see the little stop button? It's supposed to be down here.
Are you sure?
Yes. Click here to pause.